back again to our class. Now we want to start looking at the various segments that we just discussed about linear equation. Yes, in our explanations, we explained that we have various aspects of linear equation. And number one aspect of it that we are going to be looking at now is the direct linear equation. Guys, what are the things that you do in direct linear equation that differentiate direct linear equation from equation with bracket, equation with fractions, or what problem leading to a linear equation? Guys, there are two basic operations that you perform anytime you are given a linear equation question. Practically direct linear equation. Now, what are those two things that you do? Number one is to collect like terms. The second is to divide both sides by the coefficient of the variable that you are given, if any. Now, guys, what are we up to in this class? In this class, I'm going to be solving thousands of problems, but like I do always tell you, it is not basically on the numbers of problems solved. One problem can be solved, and when you understand the concept from that one question, you can solve hundreds on your own. Likewise, 100 problems can be solved in this class, and yet you cannot solve one on your own. So what is the difference? The difference is knowing the principles and the rules that are applicable anytime you are given a question of any format. All right, now, so in this class, we start solving problems and providing the necessary solutions. So we have direct linear equation on the board, and we have question number one on the board. So what do we do now? Question number one, we are asked to solve 2x plus 5 is equal to 11. I'm going to teach you one or two rules here again that will blow your mind and put you on the right track. What is the first rule now? For us, what we are going to do here to make this very, very easy for you guys is to use these two rules. One is to identify the terms that are wrongly positioned, and as well identify the terms that are rightly positioned. One, identify the one that is wrongly positioned. Secondly, is to identify the ones that are rightly positioned. Now, from rule number one, get it clear, we start applying the rules from the scratch. All right, now we had 4 rules that we explained earlier in the previous video, right? Yes. Now we want to start using the rules right now. Okay, so the first rule states that all variables occupies the left hand side, while all constants or integers occupies the right hand side. Therefore, if any constant is at the left hand side, it means it is wrongly positioned, and if any variable is at the right hand side, it therefore means that function is also wrongly positioned. So now, guys, let's identify the terms here that are rightly positioned and the ones that are wrongly positioned. Now, guys, 2x is rightly positioned because 2x is what? A variable, and variables are meant to occupy the left hand side, because this is the left hand side and this is our right hand side. All right, yes. So now 2s is rightly positioned, there is no need to move it, but this 5 plus 5 is wrongly positioned, guys. Therefore we will value. Why? Because 5 is a constant, and constants are meant to what? Occupy the right hand side. So this is wrongly positioned. Then when we come to 11, which happens to be at the right hand side, 11 is a constant, an integer, right? Yes, and it's supposed to be at that position where it is. That means this is rightly positioned. So here in this question, we have 2 terms that are rightly positioned and 1 term that is wrongly positioned. So this 1 term that is wrongly positioned is what will prompt us to what? Collect like term, so that we can take it from the wrong position where it is to the right position. Are you there, guys? Yes. So anytime you collect like terms, like we said, rule number 2 and number 3, something happens to that particular term that is wrongly positioned, that you are moving from the left to the right or from the right to the left, guys. So now let's head on. We are going to have, this is our solution. So we have 2x plus 5 is equal to 11. Now we simply say collect like terms. Yes, collect like terms. So now that you know that plus 5 is the wrong term here, all right, what do we do? all we just need to do is to put those ones that are rightly positioned and then do another thing with that one that was wrongly positioned. So we said that 2x was rightly positioned, so you put it down, then equal to, when we come to the right hand side, 11 is rightly positioned. So the one that is wrongly positioned, we just suspend it or take it and keep it somewhere. The next thing we do now is that number or that term that was wrongly positioned, guys, is it a positive or negative? Positive sign, is that correct? We now said that in rule number 2, that anytime positive sign crosses the sign of the equality, meaning from left now to right, it must change to what? Negative sign. Therefore, as plus 5 crosses the sign of the equality from the left to the right, then it turns to what? Minus 5. Guys, this is as simple as this. Then the next thing we do is to put down 2x. When we remove 5 from 11, we are going to have 6, guys. Then, do we stop here or what do we do, guys? Now, understand that in linear equation, anytime you are asked to solve, you are asked to find the variable. And anytime you find the variable ought to have a coefficient of 1 and a power of 1. Do you understand? Yes. If you have a coefficient of 1 and as well have a power of 1. Now, when we look at this stage we are now, we will discover that the coefficient of x is more than 1. Now, we said in rule number 4 that anytime the coefficient of x or of the variable is less than or greater than 1, what do? Will we divide both sides by the coefficient of that variable? So therefore, we are going to divide both sides here by 2. Happens, divide both sides by 2. Guys, then by this statement, we mean that 2x over 2 is equal to 6 over 2. It's as simple as this, guys. Then what next do we do? 2 divided by 2 is 1. Then we now have 1x. And this is equal to 6 divided by 2. Guys, we have 3. This is the answer to this very question. Guys, it's as simple as this. Now, guys, let's look at question number 2. Question number 2, we are asked to solve 3x minus 8 is equal to 10. 3x minus 8 is equal to 10. The first thing we do is to pull down our solution. We have solution, then repeat the question. 3x minus 8 is equal to 10. Now we identify that this is the left hand side and this side is the right hand side. Then the next thing you do, guys, is what? Identify the terms that are wrongly positioned and the ones that are rightly positioned using the rule number 1. And now, rule number 1, we have that this is 3x, which is a variable, and variable occupies the left hand side and is already at the left hand side. That means this is rightly positioned. Then when we come to minus 8, guys, you will see that there is no x there. There is no variable attached to 8. That means minus 8 is wrongly positioned because it is a constant. And constants are meant to occupy the right hand side. So in as much as this constant is at the left hand side, therefore it is wrongly positioned. Then we have this as wrongly positioned. Then when we come to the right hand side, we have 10 there. And 10 is a constant. And by standard, constants are meant to occupy the right hand side. Therefore, 10 is what? Rightly positioned. Now, because of the 8 that is wrongly positioned, we are going to collect like terms. Yes, by rearranging this, we collect like 10. That's all it is, guys. Now, what do? We simply say collect like terms. Now, what are the terms that are like here? Minus 8 and 10 belongs to the same family of what? Constants or integers. While 3x belongs to the family of variables. Is that correct? Yes. So, what do? Now that we know that minus 8 is wrongly positioned, therefore, we will first of all pull down those ones that were rightly positioned from the question. And what are those things, guys? 3x at the left hand side is rightly positioned. Then to the right hand side, we have 10 rightly positioned. Now, it is minus 8, guys, that was wrongly positioned. So what do we do to minus 8, guys? We will take it across the sign of the equality. Now, when a negative sign, rule number 3, crosses the sign of the equality, what happens? It becomes positive. Therefore, if we had minus 8 at the left hand side originally, as we move it from the left hand side to the right hand side, it becomes plus 8. It's as simple as this, guys. Principles are things that when you know, they make life easy for you. Okay, now here we will simply have plus 8. So as minus 8 moves from left to right, it becomes plus 8. Then we will have this as 3x is equal to 10 plus 8, guys. We will have 18. Likewise, we cannot stop here because the coefficient of x of the variable is greater than 1. And in as much as it is greater than 1, all we need to do is to divide both sides by the coefficient of x, which happens to be 3. So guys, we say divide both sides by 3. By this statement, we mean 3x over 3 is equal to 18 over 3. Guys, 3 divided by 3 will give us 1. Then we have 1x equal to 18 divided by 3. We are going to have 6. Guys, this question is as simple as this. So we are going to start. This is question number 3 on the board. We are asked to solve 5x is equal to 8 plus 3x. Right now, what do we do? The first thing we do is to simply put down our solution. All right, yes, put down our solution. Therefore, we are going to have 5x is equal to 8 plus 3x. As usual, the first thing that we do is to know that this is the left hand side and this is the right hand side. This is the first thing. Then the second thing now is to what? Identify the terms that are wrongly positioned and those that are rightly positioned. Now, looking at this question now, we will see that this is 5x, which happens to be at the left hand side, and variables are meant to occupy the left hand side. That means this is rightly positioned, right? Yes, 5s is rightly positioned. Then equal to, when we now come to the right hand side, the first term there we have is 8, and 8 is a constant, and being that it appears at the right hand side, therefore it is rightly positioned because constants are meant to what? Occupy the right hand side. Therefore, guys, this is okay. Then now when we get the next item we have them is what? Plus 3x. Guys, plus 3x is what? A variable, correct? Yes, it's a variable. Now variables are meant to occupy the left hand side and not the right hand side. Now this 3x is at the right hand side. That means it is wrongly positioned. So what do? Well, we need to collect like term so that we can rearrange this in the way it should be. Are you there? Now, what do? This is wrongly positioned. Therefore, we will collect like terms. So collect like terms. Now, by collection of like terms, we will simply first of all pull down those terms that are rightly positioned. Now, quickly, I want to teach you something. Anytime you are collecting like terms, what you are moving from the left hand side to the right hand side, or from the right hand side to the left hand side, must come to the back of the one that was already existing there. Now we know that we are taking 3x to come and meet 5x, right? Yes. Now, in as much as this 3x is coming to meet 5x, we are going to put down 5x first before we have minus 3x. Okay, down. We are going to have 5x is equal to 8. All right, guys. Yes. So we are going to put down 5x. Now this is plus 3x. Guys, when plus 3x crosses the sign of the equality, rule number 2 will be obeyed. And how do we obey rule number 2? Positive changes to negative. Therefore, we are going to have minus 3 is equal to, this guy is not moving. So we will leave it there at the right hand side. Now guys, what do? The next thing we will simply do here is to what? Remove 3x from 5x. Just like this is 5 oranges minus 3 oranges. So when I remove 3 oranges from 5 oranges, then I'm going to have 2 oranges left. Therefore, I'm going to have 2x, assuming x is an orange. All right, then this will have be equal to what? 8. Guys, at this point we are not still going to stop here, being that the coefficient of x is greater than 1. What do? We will simply divide both sides by 2, being that 2 is the coefficient of x, the variable. So we now say divide both sides by 2. So we're going to have 2x over 2, guys, is equal to 8 over 2. Now 2 divided by 2, we have 1x, and 8 divided by 2, guys, we have 4. This is as simple as we just have it. So we are quickly going to solve question number 4, guys. Please, if you have not subscribed to this YouTube channel, ensure that the number of terms, then identify the terms that are wrongly positioned. Now, in this very question we are given that 3x minus 2 is equal to 2x plus 12. Now, we have 4 terms here. Is that correct? Yes. 2 to the left hand side and 2 to the right hand side. Guys, the next thing we do now is to what? Identify the variables or the functions that are wrongly positioned, the terms that are wrongly positioned and those that are rightly positioned. Oh, this thing is sweet me for body, right? Now, so what do we do? As we have this to be rightly positioned, why? Because 3x is a variable and variables are meant to occupy the left hand side, and now it is already at the left hand side, so it is rightly positioned. Then minus 2 is a constant, and constants are meant to occupy the right hand side and not the left hand side. Therefore, minus 2 is wrongly positioned. Then when I come to the right hand side, the first term that I have there is 2x, guys. 2x is a variable, and variables are meant to occupy the left hand side and not the other way around. Therefore, this is wrongly positioned. Then the next term that we have there is minus 12, guys. Minus 12 is a constant, and constants are meant to occupy the right hand side. Now, if 12 minus 12 is already at the right hand side, then it is rightly positioned. Then we have this as good. Though we have 2 wrongly positioned terms and 2 rightly positioned terms. So what do we do now? To rightly position all of this, we need to collect like terms. So we simply say collect like terms. Now, what do we do? At the left hand side, the first function that we come first is the what? The one that is marked good, which is what? 3x. So we put down 3x, then look for any other variable, either at the left hand side or at the right hand side. Now, when we come to the right hand side, we have 2x at the right hand side, and this 2x is plus 2x, guys. So when you are given a function without a positive sign like this, it's positive, all right? It's positive. So this is plus 2x. Now, when we move 2x from the from the right hand side to the left hand side, we are going to have minus 2x. Bring all the variables to the left hand side. Now we want to arrange the integers at the right hand side. So at the right hand side, now the first one that will come, the first item that will come there is what? The one that was rightly positioned. And what was rightly positioned there? That was minus 12. So I put down minus 12. Then the wrongly positioned one, which is minus 2. So when I move minus 2 from the left hand side to the right hand side, rule number 3 will be obeyed, and that rule number 3 says that minus 2 will turn to plus 2. Then this will have become plus 2. Now guys, if x is an orange, therefore I have 3 oranges minus 2 oranges. Now if I remove 2 oranges from 3 oranges, I will be left with what? Just an orange. Therefore, if I remove 2x from 3x, I'm going to have 1x, then which is equal to minus 2 plus minus 12 plus 2, guys, is minus 10. Are you there? Yes. We simply have minus 10. Guys, this is as simple as it. There is no need to divide both sides. Why? The coefficient of x is already 1. So there is no need to divide both sides by x like we did in question 1, 2 to 3. Now, this is the very answer to question number 4. So you can see, guys, that solving linear equation is very, very simple when you know the principle. So now we are going to start solving question number 5. Now guys, we have question number 5, right? Yes, we have question number 5 on the board. So we are asked to solve 3y minus 19 is equal to 6 minus 8y. Guys, it must not all be x. It can be any of the alphabets from A to Z. It can be any other mathematical symbol, all right? It can be any of those things. Now we have y here. The same way we treated x is the same way we are still going to treat y. It's the same thing. The same rule is applicable to this. Now, what do we do, guys? The first thing we do, as usual, is to have our solution. Then we repeat the question as it was given. Equal to 6 minus 8y. Guys, the first thing that we do is to identify the left hand side and the right hand side. Of course, this is not the problem any longer. This is the left hand side, this is the right hand side. Then the next is to what? Identify the terms that are wrongly positioned and those that are rightly positioned. Therefore, 2y is variable, and variables are meant to occupy the left hand side. That means this is already marked good. But minus 19 is what? Wrongly positioned and a constant. Is that correct? Yes. Then this is a constant rightly positioned since it is at the right hand side already. While minus 8 is wrongly positioned because it's a variable, and variables are not meant to occupy the right hand side. but the left hand side. If this is done, that means we need to collect like terms. Now, when we collect like terms, we simply, so the next thing we do, guys, is to collect like terms. Collect like terms. Now, by this, guys, as we collect like terms here, what do? We are going to have this as 3y as minus 8x, guys, crosses the sign of quality, it becomes plus 8y. Can you see that? Yes. As minus 8y crosses the sign of the equality, rule number 3 must be obeyed. Then become plus 8y. Equal to, what will be here is 6. Put down 6 that was rightly positioned. Then we are going to move minus 19 from the left hand side to the right hand side. And when minus 19 crosses from left to the right, rule number 3 will also be obeyed. Then it will become plus 19. Guys, 3y plus 8y. Let's assume y is a yam. Alright? Yes. 3 yams plus 8 yams. We are going to have 11 yams, guys. Therefore, we have this to be what? 11 yams. And now, 6 plus 19, guys, we are likely going to have 25, right? So we have 25. We will not stop here because the coefficient of y is greater than 1. So what do? We are going to divide both sides by 11. So we say divide both sides by 11. By this statement, we mean 11y over this 11 is equal to 25 over this 11. What do? 11 divided by 11 is 1. So we are going to have 1y is equal to, now 25 divided by 11. 11 cannot divide 25 directly. So what do? We will find the number of times that 11 can go into 25. And that would have given us what? 2 times. Now, 11 times 2 would have given us 22. Right? So 11 will enter into 25 2 times. Now, when you multiply 11 by 2, we are going to have 22. When you remove 22 from 25, we are going to have 3. So put down the 3, then repeat the denominator. Is to what? Find the number of times 11 will enter 25. And we said it's 2 times. So put down the 2. Now say 2 times what? 11, which is this denominator. When you say this 2 times 11, guys, you are going to have 22. So to get the remainder, remove that 22 from the numerator. That's what you will have at the numerator. So when we now multiply 2 by 11, we have 22. 22. When we remove 22 from 25, we had 3. So that 3 will now serve as the new numerator, while the denominator remains as 11. Guys, this is how you do this. And this is what we call an improper fraction. Alright? And this outcome is called a mixed fraction. Understand that it is an improper fraction that results to what? A mixed fraction. So see you in question number 6. Guys, now this is question number 6 we have on the board. We are still solving the same thing, alright? So we stop at question number 8. We're not going to solve more. We're going to stop at question number 8 so that we can now look at equations with brackets, alright? Yes. Now, the first thing we do as usual is to put down our solution. Then we have 2m plus 21 is equal to 5m plus 48. Guys, what do? The first thing that we do here is to collect like terms. But how do we collect like terms? We need to first of all identify the terms that are rightly positioned. We need to first of all identify the terms that are rightly positioned and those that are wrongly positioned. So 2m is rightly positioned because variables are meant to occupy the left hand side, but this is wrongly positioned, right? Why this is wrongly positioned also, this is rightly positioned. So we have 2 wrongly positioned and 2 rightly positioned terms. Therefore, this calls for what? The collection of like terms. Therefore, we simply have collect like terms. So we are going to put down 2m, which is already at the right hand side. Which is already at the left hand side. Now we are going to move we are going to move what? 5m. Yes, guys. We are going to move 5m from the right hand side to the left hand side. And 5m there is plus 5m, guys. Is that correct? Yes. When you take plus 5m from the left hand side, from the right hand side, when you take plus 5m from the right hand side to the left hand side, rule number 2 must be obeyed. Therefore, we are going to have minus 5m is equal to, now this 48 will come first, being that it was rightly positioned right from the question. Now we are going to move plus 21 to the right hand side from the left, right? Now when we move plus 21 from the left hand side to the right hand side, rule number 2 must be obeyed. So therefore we are going to have this as minus 21, guys. Then the next thing we do is when we remove 5m from 2m, guys, we are going to have minus 3m. All right, yes. Anytime you are removing a bigger number from a smaller number, you are going to have a negative result. All right, so we are going to have minus 3m equal to, now understand that m can be mango. So if I remove 5 mangoes from 2 mangoes, is it possible? Not really possible. Yes, not really possible, but this is what we have. All right, so anytime you remove a bigger number from a smaller number, you have a negative outcome. Then when we remove 21 from 48, guys, we are going to have 27. Going to have 27. This is what we have. Then the next thing we do is that we cannot leave our answer like this, because the coefficient of x must be 1, and now we have less than 1, because we said in the theory number 4, yes, in theory number 4 or rule number 4, we said that anytime the coefficient of x is less than or greater than 1, we must divide both sides by the coefficient of x. And now the coefficient of x is less than 1. Guys, understand that minus 3 is less than 1. So we are going to divide both sides by minus 3. Then we have divide both sides by minus 3. So by this statement we mean minus 3m over minus 3, which is this minus 3, is equal to 27 divided by what? Minus 3. So now guys, minus 3 divided by minus 3, we are going to have positive 1. So we have 1m is equal to, now understand that this is plus 27. Now plus divided by minus, guys, we have minus. Yes, plus divided by minus, we have minus. Then 27 divided by 3, guys, we are going to have 9. This is the answer to this very question. Guys, you see how simple these things are. Linear equation is a very simple mathematical topic that you can solve with ease when you know these 4 rules. All right, so see you in question number 7 and question number 8, where we will end this session of direct linear equation, as we will now launch into solving problems with equation with brackets. All right, guys, see you in question number